Good afternoon, sir.
Good afternoon. You are the boss here. Okay, welcome, man. How are you? Wow.
I'm fine, thank you.
Okay. So I'm really glad that you managed to join the class. What was delaying you?
No, nothing like my Wi-Fi is being a bit slow, so then I thought it was connecting, but then I thought my Wi-Fi is being slow at first, but then I realized I've not clicked on the entered. Then when you sent a message, I said let me check on the updates, like how far is, but then I realized I've not even like clicked on connect. So I ended up clicking connect. So now I'm
Okay.
here.
Okay, that's good. I'm celebrating this. Okay. Okay. So tell me now, how beautiful is your answer that you sent to me? That's excellent. Really. Did you manage to run that answer on your replit?
It was easy because this. Okay, let me run the answer now because like it's just like fill in the blanks. So I just
Mhm.
like filled in the blanks.
Okay, but do you have any understanding when you fill it in, or you just try it? I mean, did you run it even?
I didn't like run it because but like I hope I'm correct.
Okay. So you just guessed it. Okay. But did you think about it? I mean, does it make any sense in your brain or how?
You're primarily-
Okay. I think today we are not very lucky with the internet speed. I'm hardly able to hear you, Emmanuel.
Can I please switch my
Yes, please do this switching. Yes.
okay, thank you.
Emmanuel, you still there?
Okay, so I'm so sorry. I'm on a much better network now.
Okay, that's good. Okay, share with me your reply, please.
Okay,
Do you remember that we took two kind of algorithms before, which is totaling and counting? Do you still
yeah, I
remember that?
remember.
Okay,
Yeah, I
that's good.
remember.
Yeah. So you are sharing with me something? Should I wait or I go?
No, the replay is still loading.
Okay. So you have three lines under the while loop. Is it right?
Yeah, that's right.
Okay. And um, okay. If I switch any of those lines, um, will the code still do the job or no? So is it the arrangement or the sequence is important in this case?
Yes, it's very important
Okay.
because
Uh-huh.
because like what's the word? So yeah, so like for our modulus and our so since our modulus gets us the like the modulus operator will get us the last digits of number.
Mm-hmm.
And what's it called? The integer division removes the last digits of numbers. So if we switch it, then the last digits of number will be removed and the modulus operation will occur on the wrong number.
Wow, that's a great answer. Wow, really.
Thank you.
I salute you. Wow, that's really great. Okay. Yeah, yeah, okay. Then you don't need to run. Actually, well, okay, yeah, it's better to run. So okay. Um, so far what you do in this code in the while loop, you print the last digit. But what if I ask you, instead of printing the last digit, apply the total algorithm in the code. So it means that if you enter 1, 2, 3, 4 as a number, I will ask you to add 1 plus 2 plus 3 plus 4. Are you able to do that using the algorithm that you already learned, the totaling, which is always, most, I mean, 90% of the time, it comes as part of the scenario question. The totaling, averaging normally come as a part of the
Yeah.
scenario. So tell me, is it possible that we can change or even add just single line to be able to do that? Is it rapid still loading? Wow.
Let me just share my screen because it's telling me what's it called. Uh, this is what I'm getting. It's just telling me I'm offline.
How fast is your internet speed connection?
Usually on Sundays it's slow, but I think the reason it's slow on Sundays is because like usually on Sunday, like nobody really goes out. Like it's very rare to have to go out on a Sunday. Like places are open, but people just don't go out on Sundays. So I think everyone is inside trying to access the internet at the same time.
Is it, are you sharing the internet with the neighbors?
No, I'm not sharing it with the neighbors.
Okay. So, okay, that's interesting. Did you run fast.com and see what kind of speed? Because you told me last time that you would buy like kind of Wi-Fi on your own.
Yeah, I said sometimes it's fast, sometimes it's slow, honestly. I've loaded up fast.com. So like
Okay. That's quite, I mean, not bad. 20, not bad. Wow. Okay. That's excellent, man.
so why is Replit now being slow?
That is the question that I have no answer for. 66 is not bad at all. Wow. But
Yeah.
yeah,
But it fluctuates at times. Like sometimes it'll be very fast, sometimes it'll be very slow.
I can see that. Yes, I can see that. Okay. So can you go back again to the replit with the hope that it's got pushed from, yeah, from a higher power, maybe?
Let me still reload it. Okay, let me reload it. Okay. Yeah, it's
Wow.
working now.
Okay. Okay. So are you able to, no need to,
Wait.
just please, how to say, can you replicate the code and save it under any name?
Okay,
Do you remember how to do that? Okay. Not this one. This is not the main.
yeah, this one.
Yeah. Temperature or even conversion.py, never mind. Okay. Yeah.
Okay, so so
You didn't put it? Did you put it in the py, any name the py?
yeah, any name.py, I've added the
Okay. Yeah, that's
extension.
good. Okay.
So yeah, let me write the code.
Or you copy it from your WhatsApp, or it's very hard. Should I
Oh,
invite it to you?
why did I think of okay, yeah, I can copy it from my WhatsApp. How did it just didn't cross my mind.
It's okay.
Okay, I've copied it. That's odd. Maybe there's a space.
Hmm. So it prints 0 and 9, right?
Yeah,
Which is great. Now, can you tell me, and like I told you, you already studied how to actually create the total. So I want the
yeah.
total of these two. So assume that you put 9, 1. So you add 9 plus 1, and you give me the total, which is 10. I want that to be printed out. How many lines actually you need to add? Actually, it's one line. So just tell me.
I think I what I would do would be total plus minus plus equal.
Mhm. Okay, that's good. Good start.
Okay, so okay, total plus equal number.
Interesting. Run and see. Okay, so he will tell you total is
Okay.
not defined because you did not initialize the total to any number.
Oh, okay. Let's see if it'll work now.
Okay, it doesn't work, definitely, but or even it works, but we didn't see. Just print total. Okay, that's excellent today. Interesting. So you give me 0. Okay, it means that we didn't add anything to it. So what about when you initialize? I prefer that you initialize maybe on top of the program. So make all your
Okay.
initialization as a habit at the start. Okay, that's good. Try to run one more time to see if that have an effect and you will not get the zero. We're still getting, okay, put 9. Yeah,
Yeah, we still
okay, we're
got the
still getting the
zero.
zero. Okay, so this line, what you did, okay, what about if we want to troubleshoot what is happening? Can you do a print?
If you want, could you please repeat yourself? I didn't hear what you said.
Okay, we want to troubleshoot what is really happening. So I would
Okay.
say print here number. I want to see what is the value inside number.
Zero.
So yeah, okay, it means that when I tried, so what I'm trying here, I'm trying to add 0 to 0. Total have 0. And you add another 0 to it. Wow, that's interesting. So give me, of course, 0 lah. So you don't expect anything from this kind of addition. So could it be possible that this line that you're putting is actually in the wrong place? Maybe it needs to be
Which what like which line?
line number 9. Could it be that line number 9 need to be um, within the while loop? Possibly? Is that possible?
Yeah, yeah. It's oh, I accidentally copied the two lines.
So very, very important that you memorize the algorithms of totaling and counting by heart. Still, when you don't indent the code, which is line number 7, it doesn't, it means that this code, this line does not belong to the while. You have to indent it. Okay. Yeah, that's good.
Okay.
Now run. So it gives me 9 at the end. That is excellent. But to be able to 100% know if your code is correct or not, put 1, 2, 3. Okay, so can we have a look here? Is that the result is correct? You're getting 13, isn't it?
Yeah.
So what does this mean? Means that you are getting correct or no?
Um,
Mhm. Any idea why you are getting 13?
because like what's it called?
So
The last digits of 1 to 3 would be 3.
okay, so okay. When you take out the digit and then, so this is 1, 2, 3, 1, 2, 3. So we have to analyze. Okay, when you modulus 10 with 1, 2, 3, what is the result? What will be inside digit?
12.
And no, it will be 3. This line is extracting the last digit.
Oh, sorry. Oh, okay, okay, okay.
Okay, so
Yeah.
again, we print that out. That's why you see the 3 here. And now, if we take 1 to 3 and make an integer division to it, so the result is 12. So it means that we save 12 inside number. Okay, and then the next line you say, I want to add total to the number. So the total have 0. So you add 0 plus 12. So far, it means that 0 plus 12 equal 12. It means that you actually store 12 inside total. And then you run the code again. So when you run the code again, we will,
Okay.
okay. Now, do you understand? Did you start to understand what is really happening or? Where are you now? Because I know if I explain into details, you are gone. You are not with me at all. I know the story. This movie I saw it before. So
Yeah, okay, wait, let me think about it.
yes,
Okay, so
yes, it's better you think, not me tell. Yeah.
okay, so
Just as a info or something to remember, our target is to add 1, 2, and 3 because those are the numbers that we need. 1 plus 2 plus 3 should result in 6. But now the problem is we are getting 13. So it means that our algorithm have a problem. We need to fine tune it. It is true that you only need to add one number and one line, and you did it. But it needs fine tuning because it's not 100% correct.
yeah,
And one more hint, this 13 is actually 12 plus 1. Of course, it's I mean, yeah, it can be 6 plus 7 or no, but in this case, exactly, it is you are adding 12 plus 1.
okay, so so after this, would that be like another modulus?
No, 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 no need. No need for anything. You are adding 12 plus 1 because the first integer division will actually remove the first digit. So our number now will not have the last digit. So it will have 12. And you added this 12 to the total. And the second time you run, you will you will actually remove the 2 from the number. And you add this 1 to the total, which is already having 12. So that's why when you add 12 to 1, you will have 13. The target is not to actually to put number inside the equation here. The target is to add the digit that you extract. So every time, like if you look at here, what is important to him? Does he print the digit or the number? The digit, because the digit is the one
Digits, yeah.
important. So can you try to remove this number and put a digit instead?
Okay,
I repeat again.
to remove this digit,
No, no,
we,
no. You lost me. Okay, so you remove
uh,
the number, put digit instead.
okay, okay.
Okay, now put 1, 2, 3. Do you see 6 at the end?
Yeah.
So we cannot solve code by guessing. If we guess, we are lost. The scenario question can never be solved by guessing. That is a solid, maybe at least 20 lines of code, minimum 20 lines of code, cannot be done by guessing. I'm just building with you the structure. I mean, I'm building the knowledge inside your brain. If you don't know the basics, so when we try to write a longer code, we will get lost more and more. So just please bear with me, revise your code and your slides, please. I just
I
beg your
will.
pardon. I know when you did it, your performance was excellent. But yeah, so and then you drop again, you drop down again. So yeah, okay, no comment. I will only resort to Mr. Ali once I got no choice. So I
Yeah,
hope I don't do that. I hope. So
me
okay,
too.
okay. Now let me have a look here. Mm, tell me, okay. So I think I will not risk that we keep all the times only doing coding. So let me try to share with you something other than coding, which is the logic gates. So
Oh, yeah.
so what about the logic
Okay.
gates? How good are you in the logic gates?
Uh, Logic gates is like it's interesting. That's what I can really say. Like, I can identify logic gate and output, but sometimes I get a bit confused.
Interesting. Um,
Like, I can identify the gate. This is the first. This one, like, and or not, XOR, X and
do you
wait,
remember? Okay.
or
Yep. Yeah, I'm listening. It's good.
and
Talk. Yeah.
and or not NAND nor exclusive, or we use NAND in solid state storage as well as NOR, and then we use the rest for like just basic logic gates that say.
Okay, that's excellent, excellent summary. Um, okay, the most important, since you already know, did you know why we are only having true and false, or even one and zero in
Yeah,
a single?
because
Mhm.
for computers process data using logic gates, which only have two states, one or zeros, and computers are made out of transistors, which also only have two states, one or
Excellent,
zero. I
excellent.
mean, on and off, as well as like switches
Okay,
or positive, negative,
so
anything really.
that's excellent, excellent so far. Yeah. So yeah, it seems that there is area that you master, uh, mm, yeah, master badly. So I would say, what is the logical operator? So you I think you already know the logical operator. Do you know that this is the Boolean operator? This is how the AND looks like, and the OR looks.
I've not seen like the signs, but I know like and or not. Like,
Okay. So
yeah,
did you see that?
I've seen it before, but I never really like bothered to find out like what it is.
Okay, so you can. It is possible that that the AND is expressed this way, and the OR is expressed this way, and the NOT is expressed with A, and there is a dash on top of it, which refers to NOT. So we are inverting it. We are inverting the A. So this not A. We will see that in the logical expressions. So since you already know the basics, I would actually move here. Do you memorize the truth table of all the gates or not yet?
Uh, I feel like sometimes that's not everything. Like for something like this, I feel like you can just like derive it. So like not is that's the inverse, so 1001.
So you
So
don't need to
yeah,
remember that yet. Okay, that's good.
I don't think so.
Yeah, okay. It's good that you do it this way because that's the only way. So you don't confuse yourself in the exam. Okay.
Yeah.
The AND gate. Can you tell me how can you drive that? How can you
So
drive
an
the truth
AND
table?
gate will
Mhm.
only give you, so how I imagine it is with the circuits, an AND gate will only be positive if both of the inputs are positive. That's why there's like and.
Excellent.
So
Excellent.
yeah,
Yeah, that's excellent answer. Now, what about the OR gate?
or is a very good gate. As long as it sees positive, it'll just output positive. But there has to be a positive.
Okay, excellent. Excellent answer. What about the NAND gate? Do we need to
NAND
memorize the
gates
NAND?
will NAND gates is a bit weird because you need two negatives. What I like to describe it as a wicked gate. It needs two negatives to be positive. So like that's how I remember it.
Can't we say, since we are finding relationship between, I mean, to build the truth table, we need to only remember certain relationship. Can't we say that
Yeah.
it is invert in the it is the invert of the AND gate. So if we say
Oh
that,
yes, yes, you could
so
think of it like that.
so if we say the AND gate is 0, 0, 1, this is the truth table of the AND gate. So you have here 0, 0, if this is A, B, and this is X, so 0, 1, 1, 0, 1, 1. So that is the AND gate. If you want to invert that, so you have to invert this. So it means that you have 1, 1, 1, 0. So you don't need to actually memorize it. You just only need to understand like what you did. Just that the AND is not the NAND is not AND. So it means that you just need to memorize the AND very well, and then you are able to drive the NAND from it.
Yeah.
Okay. And the same goes with NOR. So it is the opposite of the OR gate. So if I say a NOR, so I not the OR. So I need to just list what the OR truth table is, and then I invert it. So if I say here 1, 0, 0, 1, 0, 0, what is the OR gate? Truth table.
The OR gate is that like to get one, we need at least 1 0.
Okay. So if two zeros, then we get 0. Okay. What about 0, 1?
Um,
This is the OR gate. You just mentioned just now that you need at least one positive to be
yeah,
able
you
to
need
get
at
one.
least one.
So
Yes.
so if I see here 0, 1, there is one positive, so I put 1. So 1 and 0, I see one positive, I put 1. I see two positive, I still put 1. So that's the OR gate. So if I want to invert that, mean that I get the opposite of that. So it means that the NOR should be 1, 0, 0, 0. This is the NOR gate. So I just only need to memorize the OR, and I can drive the NOR from it. So far you following up or I lost you?
Yeah, so far I'm following up.
So, okay. Um, that is okay. Now the XOR is quite strange. So this you
Yeah,
have to,
it's an exclusive or so either it has to be like exclusively one to get one, or like there has to be one, but there can't be two ones. That's how I like to describe
and
it.
it can't be two zeros. So it means that
Yeah.
we need an input that is not the same. So when the input is the same, then we don't really get a proper output, or then we don't get a positive output. So it means that when both of 0, it means that we still get 0. If both are ones, we still get 0. We need the input to be different, 1, 0 or 0, 1. Only those will produce a positive output. Does this make sense?
Yeah, it makes sense.
Okay. So how far did you go when combining logic gates? Did you solve any exercises or even past exam questions?
I think one or two.
Okay, let's have a look then. So can you recognize that we combine two gates here to get an output here? So can you see my screen?
Yeah, I can see your screen.
So what is the effect of putting a NOT gate after the OR gate?
It will just inverse whatever results you get.
Okay, excellent. And then I would say, um, so let us learn the concept on this simple gate. So can you see here?
Okay.
We call any middle output as an intermediate output, and it's very important to put that. And did you learn that? Okay, so this is an intermediate output. You will never be able to reach X, which is the final output, unless you list all the intermediate outputs here one by one. So you need to list them. I mean, here it's only one intermediate output. So you list it like that, and then you start to invert it or just bring the X out of it. Okay, let me move forward. I know I will lost you if I talk too much. So
No.
yeah, I think I also need to learn from you. That's interesting. Yeah. Uh, yeah, I mean, so this is like an experience I am getting. Uh, this is the first time I taught the person before. Um, he was from UK and he was also I think maybe have origins from Africa, I believe. So, but he was quite smart, and I mean, he doesn't. Maybe he have a communication problem. So this is, but he very 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 smart. Um, so yeah, it's an experience. Every time you
Yeah.
you teach somebody, you get his brain works different. God creations are totally different from each other. We are not robots. So okay,
Yeah.
now we have two gates here, or three. How many gates we have?
We have three gates.
Okay, how many intermediate outputs we have? Do you know what's the mean intermediate output?
Yeah, the intermediate outputs will be is the inputs one?
So this is A, B, and C. This is all inputs. So A, B, and C, this is inputs. Intermediate outputs is P and Q. They are not the final output, but they are output from certain gates. So they are output in the middle that help me and allow me to reach X, which is the final. So X is actually, I can only drive it once I know its input. So I need to know the P and Q because they are the input of the AND. Is that an AND or NAND?
Um, this is an and.
Okay, that's excellent. So, okay, if I have,
The NAND has like a dot.
excellent. So the NOR and the NAND have a dots, right?
Yeah.
Okay, so if I have three inputs, do you know how can I build my truth table? How many inputs I need to list or how many rows I need to list in the input?
You need to input three. You have to have use three inputs.
Okay, that is excellent. So if is it the calculation is like that, 2 to the power of 3, and this 3 represents the number of inputs? Is that like that?
Yeah, it'll be
Did you
like
see
that.
that before? So do you see that uh, if I say 2 to the power of 3, it means that I need to have 8 rows of input. So I would say A, B, C like that, and then there is certain way. If you memorize it, then you will be able to write the truth table fast. So the first one you
Yeah.
write zeros and ones, and then the second one you write 0011, 0011, and then here on the last one you see 0101, 0101. So of course, when you memorize it this way, then you will not make mistakes and you will not um, consume energy from your brain during the exam. So that is also one of the tricks here. So again, based on the number of inputs, then we decide how many rows we need to put. So can you look here and tell me if you understand anything from the slide, please?
The more inputs in the logic circuit, the more possible yeah, so the more inputs, they're just more outputs because we're calculating with more inputs.
No, 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 no. We base, so here is two inputs, A and B only. So 2 to the power of 2 give me 4. So these 4, you see them here. This is the 4 inputs that you get. You get A and B, only four rows, 1, 2, 3, 4. If you got 3 inputs, so that is 2 to the power of 3, it means that we have 8, which means that we have 8 rows, 1, 2, 3, 4, 5, 6, 7, and another one down. So that is 8. So far clear? I mean, that is the basics of building a truth table. If you know it, I mean, it's all calculation. So does it make sense to you?
Yes, makes sense to me.
Okay. So, okay. Can you tell me if this P, the intermediate output P, is actually correct or not? And what gate should we actually be talking about? Did you see a truth table like that before with intermediate output?
I think I'm not really. No, I don't think so, actually.
Oh, okay, that's interesting. So you didn't see how we write the B and the Q. Okay, now the B is what? The output of what?
Um,
This is what gate?
0
Which gate is that?
or
So the OR, the input of the OR is what?
yes.
Guess what? What is the input of the OR?
Oh, 0
No, who said? So, okay,
inputs of or. I
yeah,
thought it was 0.
no, who said? So A or B, and actually the result is P. So that is what is the P is. So again, if we want to get this 0, it means that we need to OR these two. If we want to get this 0, we need to get also OR these two. So you see here, is that correct output? When we see 1 here, because of the two inputs 0 and 1, is that the OR gate?
Yeah.
Okay, can you confirm to me that all those is correct or not?
I'm going through it. Yeah, I can confirm they're all correct.
Okay, so can you tell me now, if we have another intermediate output, which is Q, what is the output that I need to list down here in for Q? What is your input for this NOT gate?
Um, not A or B.
So
Not
it's
C.
not C.
Not
Okay, so
C.
the input is C. The input is not C. I mean, the input of the NOT gate is C. So, okay, if you have C here and the C is 0, so the output is?
Um,
Mhm. Are we thinking? Are we thinking? If you
yeah,
if
we're
you start to
thinking.
think, no, wait. If you start to think, then my advice, like the other student, would be before you start to think, start to think that it means that it's not 100% fixed in your brain. So there is a chance for errors. So okay, the NOT gate actually, sorry, I apologize here. It actually have one input. So we can say that it is like C. We have here 0 and 1. And the NOT gate produce, if we see 0, we put 1. If we see 1, we put 0. And the same goes here. So if you start to think, it means that they are not memorized yet. You need to, before you even think about that, you need to list all your truth table here, and the same goes to the end. Now, I already listed for you the truth table of NOT. So look to me here and tell me for the C0, what should I put as the output?
Um,
You see here, look at here. When you see 0 as an
oh,
input,
1.
okay? And when you see 1 as an input, what do? Here is 1. So
The
this is,
outputs will then be 0.
okay? So again, this is the input. What should be the output?
No, 0, sorry.
So when I see the input 0, you get me 0 or 1? Huh.
One. Like it's just a reverse.
Yes, I understand, but why you're confused? That's why, that's my question. So here is one. If I invert with a not, where are you?
Yeah. It'll be zero.
Okay, and
This will be one,
okay,
zero, one, zero.
okay. So let me put it this way. Okay, tell me the truth table of the AND gate.
Um,
Mhm.
so we could, this is for the AND gates, right?
Yes, yes, this is the AND gate. Yes.
Okay, so zero, zero, that will be zero,
Mhm.
zero, zero, one.
Okay, that's excellent. And okay, so can we now use that to produce the X here? So if we have, I mean, the AND gate is the one that is going to give me the final answer. If for every column that you make correct, actually you got a mark. So if you didn't do the final output and you did the intermediate, you will actually lose only the 1 mark for the output. So that's how they mark it. Now, if you have P and Q like that as an input, so this is your two inputs that will produce the X. Look at this table and tell me when you have 0 and 1, you go here 0 and 1. What do you put here? 0? Is that
Yeah,
correct?
yeah, that's correct.
Okay. Is this two correct or wrong?
These two are also correct.
No, no, you are dreaming. You are dreaming.
Um,
Yes, it's true. How come 0 and 0 as an input? 0 and 0 produce 0. This
oh,
is,
wait, okay, I have a question.
yes,
So
yes.
if we have these inputs, why are we looking at intermediates output like for the like what's the point of this whole row? Like these two? I don't get it.
That, wow, man. Wow, man. Yes, I like that question. Really. Okay. Yeah, really. It means that you start to, yeah, that is actually excellent. So, okay. When you have you're talking about when you have the input like A, B, and C, why do you need to have P and Q, right? Why can't you
Yeah,
use A, B, C directly, right? But is it
right.
okay? Okay, is it the output X related to A and B or related to P and Q? What is the input of the AND here? Is it A and B?
Okay. Um, it's P and Q they're asking us.
So unless you know the real input to the AND, then you will never be able to produce the correct X. You need P and Q because they are the inputs to your final gate. And sometimes we have more layers. Sometimes you even have 3 or 4 intermediate output. So, and those intermediate output is the input to your final gate that will help you produce the X. And they are not related to A and B at all. So X is not related to A and B. X, you can only drive it if you know P and Q. If you don't know P and Q, if you don't write them properly like that, then you will never be able to. If you just put it in your mind and you don't write them, definitely you will make mistakes. So you will lose. So you need to
Yes.
really write them. Okay, now uh, that is an interesting question. I know that it will take you time to digest that. It seems that you didn't write it, you write those before, right?
Yeah.
Okay.
I haven't.
Okay. So for these two, please confirm to me if my output is correct. I'm using again an AND gate. Look at the zeros here. Look at the ones and see if those output here match what I write here.
Okay, okay, so um
Okay.
wait, if there's an AND gate for 0, 0, how come my output will be 1?
So it means that it's wrong. That's what I want to hear from you. It is wrong.
Okay, okay.
So I put it, but yeah, I just don't want you to keep agreeing that it is correct and without really thinking about it. So it is zero. Yes. And what about the one?
That would be 1.
Okay. Um, then I would say, um, let me think with you. So you have 1 or 2 minutes to drink, to go and drink something, and then come back to me. I will also go and drink. Okay.
Okay, no problem. I'm going down.
Okay. Emmanuel, are you ready?
Me too, so I'm also ready.
Okay, that's good.
Did you stop sharing because like your screen stopped showing?
Yeah, yeah, I did. Just give me a second here. Okay, so I will just move a little bit here on this slide.
Okay,
So
fine.
we will say how,
I'm sorry, what did he say?
so we will take how to, for
Build a
how, if
truth
we
table.
get,
Okay.
yes. So from a circuit, we will build a truth table. So let us see how we do that. So this is a circuit. As you see here, we have multiple layers. We still have three input, but the output is quite far. So it means that we have many layers to go through. So can you tell me what is this gate?
That's an or.
This is an O, you sure?
Yeah.
With a knot like that? With
Oh,
a
that's
third?
a dot. I thought it was like a connector. That would
No,
be XOR.
no. I'm sorry again. No, it's wrong.
Oh, no, sorry.
Okay. And what about this and this? So this is what?
Now, is that still a dot or like a normal one?
No, that is, I mean,
Okay, then
if,
that's or.
okay, that's good. Okay, what about this?
That's a and.
And the two arcs.
That would be a XOR.
Okay, so I mean, you already took with me how we do the intermediate output. So how many intermediate output I need to put here?
That would be two. One, two. Wait. Uh, two raised to the power of four.
Mm,
No,
interm
four intermediate outputs
okay, so the first one should, where should I put it?
here.
Where is here? I can't see your hand.
Oh, like here.
Okay, so what should I call those two?
Let's just say X.
Here there is X. So the final typically is X. Okay, so can we
Oh,
say,
sorry. Okay, let's put like G.
okay, fine, G and
Um, G, and then this one will be, let's just say P.
okay, that's good. P, no problem. So here G, P, and then what is the input for the XOR?
Um, I'm sorry, could you please repeat yourself?
Okay, I will repeat myself. What is the input for the XOR?
G and P.
No, who said the G and P will produce an output, and that output will be the input for the XOR. So it means that we needed another intermediate output here. The G and P is the output for the no, G is output for the NOR, P is output for the AND, and again here we have a C as an input. So that is okay. There is no need for intermediate. But with this, we need to call it something because that is the output of the OR. So the OR have two inputs and it must have be an output and you need to call it with a name because again it's entering another gate. So what is how you call the input here?
Uh, that would be um.
MNX, I mean MNY, OK, anything. I mean the numbers is
Oh,
the
okay. Let's
part.
just put A. No, we can't put A.
Yes, of course.
Let's put K.
Okay. So how many again? Let's again see how many intermediate outputs we have. G, P, and K. So far clear. So if
Yeah,
you
so for us, clear.
so okay. So the steps that you need to follow for every solution to this kind of building a truth table. So from a circuit, then you actually need to follow this. Identify all of the possible combinations of input. And we know that the inputs is actually three inputs. So we say 2 to the power of 3, it produces us 8, which is the number of rows that we need to use inside the truth table. We need to work out the solution for intermediate outputs. So it means that we need to choose and identify and write the intermediate outputs, which we did. Use the intermediate outputs to construct the final output. So you choose to have P, G, and K. So, and your input is A, B, and C. So you have to list your inputs and then you start to get what is the content of P, J, G, and K. After you do that, you will be able to easily put X. X is a relation between K and C, these two. So, and the P is a relation between A and B. And what is the relation? It is an NOR gate. I think you're not with me anymore. I lost you. I
No,
lost
I'm
you in
with
the
you. I'm
middle.
with you.
Okay. So again, what I want to say now, you already know you have three inputs. It means that you have 8 rows like that. Okay. So the second would be to identify all the intermediates, which is okay. He used um, um, different naming. It doesn't matter. The P, Q, R, or even the P, G, and K is all the same. It doesn't matter the names. The most important is that you have an intermediate output. You need to mention it and you need to start listing it in the truth table. So if you identify B, Q, and R, so you put them, and this is the P as a start, and then after that you put the Q and the R. So the P is what? The P is the output of this NOR gate. So it means that you need to draw this truth table of the NOR gate, and then you start to see this is the two inputs. I need to build this based on the input from the B and the A. So every time you check here, are you able to tell me the NOR gate truth table 00011000? Tell me what is the output here for the NOR gate.
For the NOR gate is going to be 0,
Okay,
0,
okay.
0,
Wow, okay.
and 1.
Actually, I made a mistake here. So that should be 1 and 1, not 0 and 0. Okay. And you also did not realize it. So I put here 1. Is that true?
No, I said 0. Oh, wait. Wait. Ah, it's confused.
So
Wait.
is that the OR gate or the NOR gate?
Oh, this is NOR.
I don't think so. I don't think so. So I mean, okay. So if I say that this is the OR gate, I mean you can drive the NOR from the OR. So first you need to list the OR. The OR say that if any input is 1, then we got an output as 1. So the NOR is an inversion of that. So how to invert that? It means that I put 1, 0, 0, 0. So it's not at all what you mentioned. It's far from what you mentioned. You again, you and I mean you mentioned theoretical thing correct, but you do not know yet how to apply that knowledge. You have the theoretical knowledge that okay, what is the nor and what is the or, but you don't know how to apply that. The truth table, writing it is less confusing for you when you try to apply, because if you have to think, the chance that you do a mistake is high. If you write the truth table and you just, it is enough just to look at this and then apply, because you write the truth table, you only write how many times you need to think, only 4 times to build these rows. And but how many times you need to think here? 8 times. If you build this, it is just a matter of copy and paste. Okay, here the two input is 0. So I look here, oh, I find 0. So I put 0. Okay, so it's like that. But just be aware that the P is not OR. Huh? The P is for the NOR. That's why when you see the 2 zeros, you put 1. So, okay, this is in short. I will stop here. Okay.
Okay.
You already left me. Okay, I understand.
No.
Okay. So okay, so since you already left me, the remaining of doing the truth table, which is the P, Q, and R, is actually a homework for you. So you need to try and let me see how you practice that, and that is very hard to get assistance from anywhere. So that is, I think I will be happy to
Yeah.
see your effort here. Now let us have a look at this. Just only less than 10 minutes we can finish.
Yeah.
So the last thing that you did with me was okay. Yeah.
I'm sorry, what did he say?
No, I didn't say anything yet. I'm just trying to open the slide. So it's only like 2 or 3 slides that does not need anything from you in writing. Just only 3 or 4 minutes, we close. I will not stress you too much. So I just only need to get your focus. If I get your focus and instead of doing this in two sessions or classes, we finish it early and then I will stop you early. Now, what we need to do, we already learned about mode and this integer division, which is div. We still need to learn and actually exercise about random and round, but I will not do it now because we don't have too much time. I just want to share with you how to write a maintainable program. So if you want to have a program and if you want to ever become a programmer, you actually
Yeah.
need to make your code understandable. Most of the time, you as a programmer will not write code from scratch. Because again, writing a code from scratch is quite very rare. And typically, when you write a code from scratch, you need to be senior enough. So typically, when you go
Yeah.
to a company, they will give you a code that is written by some old programmer or even a programmer that already disappeared from life. And then they will ask you to, yes, it's true. Yeah. But most of the time it's like that. The code will come with no documentation and it is horrible like hell. You don't know, it's like a spaghetti code. Yes. And they will tell you, oh, try to understand and try to change it to do that. The customer wants you
Have you
to,
ever like worked on a code like that? Like that's
yes,
extremely,
definitely. Uh-huh. Yeah,
oh,
extremely what?
like unmaintainable. Like
Yes, yes,
it's
yes.
just,
Yes, it's true. I mean, you have to understand that. Okay, so it's some untold secret that I mean, here in Asia, I'm living in Asia. So when
yeah,
I when I work for companies, it's not they are not following the I mean Europe and US regulations and maybe procedures in writing code. So they, I mean, especially in Asia, you have 4 projects in hand, and you need to work on the 4 projects at the same time. So you need to sometimes you need to become a monkey to be able to do that. I bet again, yes, I mean, I understand the environment. So I'm telling you based on what I have seen. So you have four projects, and they cannot afford to bring four programmers for each to work on a single project. This is not Europe. So Europe, yes, okay, you
Yes.
work from 8 to 5, and maximum you stay until 5:36, and then you leave. It doesn't matter. You have 10 projects, 20 projects, doesn't matter. The time for leaving comes, you leave. But in Asia, no, it is not the case. If there is a delivery for one of the four projects, you have to. So again, documentation means that you're writing code that people can understand. It's not important. The most important that you deliver. So deliver means you don't care about the quality. So that's why big chance. I mean, I can't blame the
Yeah.
programmer. The programmer is a human. He want to go. He want to get to find his earn his living, and he does. He also want to go back to his family. If he write a maintainable code for a four project at the same time, that will never be good for his life. He will kill himself. So yeah, yeah, it's
Yeah.
true. That is really true. I'm not telling lies. I have seen like that before. So I want you to look at this code. This is exactly the
Okay.
code you wrote. I mean, it is just conversion for the temperature. I don't say that you write AAA. I'm just telling you
Yeah.
that this is the same formula that you did. So the formula that you did, you write it actually in a few lines. So, but we can shortly write the whole thing in the return. So it means that I don't even need to save the result in a variable and then return the variable. I don't need that. Actually, yesterday you write return cell like that. And you write cell equal, and then you put the formula. So you don't, even this step actually it's not needed. You don't need even to create a variable. You can just put the whole formula like that. But as a junior, that will be very hard on your heart. That will you will not accept it easy. But once you keep writing code, you will learn that if any shortcut you can do, it is good for you, because it means that the less code that you write is the less time that you have to spend at work. And now you are learning. Nobody is paying you, so you will just want to make everything simple and clear. But at work, you want to write less code. Less code means you finish fast. So if every time you know how to write a shortcut, it means that it's good for your life. Okay. So again,
Yes,
you
sir.
write it like this, the way that you write it, which is creating a cell variable, then return cell, also fine. But the only thing that I would like to highlight to you here, you write a name that people can understand. Anybody look at the function name, he will understand Fahrenheit to Celsius. But when I write a function name that is called AAA, or even conversion, or even operation, like what you wrote, I mean, nobody can ever guess this operation means that I need to convert the temperature from Fahrenheit to Celsius. Who can guess? Based on what we can guess? We don't know. So it is better to write a name that people can understand. And instead of saying X like this, you better write a name that people also can understand. So you name it Fahrenheit instead of X. So, and instead of writing just num, like what we did, so you just write a name that we also can understand. So you see here, I'm calling the function, and then I'm saving whatever returned from the function into Z. So what is Z? It's also not known. It's supposed to be Celsius. We are getting, after the conversion, we are getting a Celsius temperature. So we need to call it Celsius so people, when they read, they can understand the code. If you don't start with this concept from the zero beginning when you are writing a code, then whenever you write a big project, you will follow the same shitty style that is used here. So,
Yeah.
okay, if you understand what I said, just tell me what you understood, and then we finish the class.
So like to make a program that's maintainable, which is basically a program that allows other people to like work on it and is clear to understand, you have to use meaningful identifier names, like names that are universal and names that everybody can understand, instead of something
Excellent.
that only you understand and remember. So
Okay,
yeah.
okay. Once I have an internship in Germany, That was a work in a software company, and that was almost in South Germany. They was building.
Yeah.
Okay, so this company was building some kind of sophisticated software with hardware. So at the bottom floor, they build hardware, they assemble circuits, electronic circuits, and on the top, on the second level, they actually they have a lot of software programmers, one whole big floor full of programmers, and they have programmers from
Yeah.
different areas. So they have from India, from Turkey, from Russia, from everywhere, and other are Germans. So the point here that they write a software that can run on a ship without operating system. So, and even if they use operating system, they use something called real-time operating system. The software that they write can be used for cars, can be used inside airplanes. So did you know? I think you already studied that in that um, there is a microprocessor inside um, certain devices inside the car. So the brake,
Microcontroller.
okay, let's say microcontroller to make it easy. Okay, fine. The microcontroller have a software. Okay, and so there is a microcontroller to control the ABS. You know what the mean ABS?
Wait, could it ADS?
ABS. The ABS is responsible for the braking of the car. So this is a system that
Automatic brake system.
not automatic, anti-slip braking system or anti-braking
Oh, okay.
slippery. So it does not make the car slip on the road. So slip means that you press the brake and then the car still keep moving. And but it's it's like slipping on the asphalt. So that system, if you have it in a car, it will prevent the car from slipping. So when you really press, it will really stop and it will not even drift. So that is, I mean, it's even an old system. And if you living in a country that have a lot of raining, then you must have an ABS or else big stories happen. So again, an ABS, there is a microcontroller or microprocessor system with a software
Yeah.
that is responsible for it. So how many microprocessor or computer system inside your car? A lot. So for the entertainment system, you have a microprocessor and a computer system. For the how to say the driving wheel, which means that how to say the power steering, you will also have another computer system. And for the braking, you have another computer system. If you have some advanced feature in the car, which is apply auto braking, when the sensor detects there is a car in front of you, you will also have another microprocessor for that. So it's not like a computer. You have one big computer that do everything. No, you have a small computers, each do a specific job, and they all talk to the main computer system. But they only need a dedicated microprocessor for every specific purpose. I think, did you study that in the theoretical chapters?
Yeah,
No,
something about microprocessor, microcontroller.
you didn't study automation, the automation side, did you?
Oh, yeah, that's in chapter like robotics. Yeah, something like that.
Okay, that but automation was before the robotics. The robotics, yes, it's part of it. And okay, so did you study that you take your inputs from the sensors and then you convert that using the analog
An
digital controller,
ADC. Yeah, yeah,
ADC?
I remember it.
Okay, so that is exactly what the, my colleagues on that German company was doing. So they have a circuit that is built for them, and of course it's built for the customer, and they need to build to be aware of the software, and they need to write that. So they applied. I personally was just an internship, so that was at my early days in programming. So I saw the people, wow, writing so complicated code. Wow, it's thousands of lines, it's too complicated. They have to understand the hardware first before they even write a single code. And they was using a language called C++. That was in 1999 and in 2000.
Oh,
That's quite long time ago, 25 years ago.
yeah.
So, okay. Um, I think now you already saturated enough and we need to finish, but I still have to find a way to help you with ICT. I still did not find a way yet. So may I know, can you tell me or find out what version um, of Office you are using in your school?
I'll find out.
Okay. And what version of Office you have on your computer?
I have LSTC.
LSTC. What is that?
I don't even know. It just shows.
Yeah, but I mean, is it Office 2020 or 2024, 20, I mean, 2010 or what kind of, what version of Office? Can you just do a
Ah,
print screen to me from your office, how it looks like?
okay,
Okay.
I will.
Okay, that's good. Okay. See you next class. Thanks a lot.
You too. You
Today
too.
was much better than yesterday. Thanks. Okay. Take care.
You too. Have a great day.
Same for you. Bye-bye.